Hi, this is the first tutorial about how to use Tiberlab software in order to simulate devices in structure, non-structure, and a lot of different systems that you can simulate with our software Tiberlab. I will show you how to use our input file for Tiberlab and first of all how to create a geometry, a structure, in order to be imported in our script file, and how to create the structure and how to mesh it. I will start with a very simple model, which is as you can see here in example 0 from our example tutorial, which is a bulk silicon. Okay, so here I have this file, which is bulk.geo, which is a script file for the program Gmesh. You have to use this Gmesh program, which you can it's open access program. This is the 2.10.1 version. So in order to show you step by step how to write, in this case a very simple model for silicon, I have here created an empty file in which I will copy step by step all the line in order to show you how to create the geometry. In this case we have a 1D geometry. Okay, just copy the first 4 lines here. So here we have 2 points, point 1 and point 2, with an array with 4 members of the array, and here 2 parameters L and D. Every information, every line should be handled with a column, as you can see here. You can define variable or constant as here. So here you have this L equal to 1 and D equal to 0.01. I will show you in a while how does it work. Okay, just save it, and here I will, from Gmesh, the program, I will import from this folder example 0 this file bulk01 geometry. Okay, here you can see we have 2 point 1, point 2. So you can imagine what does it mean here. So the first 3 members, the first 3 numbers of the array are just the coordinates in the Cartesian system of this 2 point. So here we have x, y and z. So for the first point we have 0, 0, 0. From the second point we have L, which is 1, 0, 0, 0. So you can put a number, of if you have already defined a constant, you can just write the name of the constant here. Here you can see it, point 1 from the cursor, we have point 1, 0, 0, 0, and then you have point 2, which is 1, 0, 0. It's fundamental to remember that if you want to simulate a one-dimensional structure with Tiberlab, you have to draw it along the x-axis. By default, Tiberlab in 1D work with structure which are along x-axis. So that's why we have 0 and 1. So it is 1 point at 0 and 1 point in 1. The other 2 coordinating, since it's a one-dimensional structure, of course they have to be equal to 0. You can see here that we have another information, which is the mesh size, which is 0.01. Of course, this is the 4th members of our array, is D. This number here is very important because it gives a measure of the mesh. So the smaller the number, the more precise it will be the mesh, and vice versa. The greater it will be less precise, more coarse, you can say. But so of course this is a choice you have to do, and depends of the precision you want for your system. So now we can copy the another information here in our file, which is line 1. This is clear, the syntax. See, line 1 is line from point 1 to point 2. It's important to remember that in the syntax that the line have a sign. So this line goes from point 1 to point 2. So it is positive if you go from point 1 to point 2. Otherwise, you have to remember it's a negative. This doesn't matter here in a very simple structure, but when you have to build more complex structure and you have to create some surface, you have to remember about this. So okay, we just save it, and here we go to geometry and we put to reload. Okay, here we have the line 1 from point 1 to point 2. Okay, for this simple structure we are almost at the end. Since now we are just to write this information, which is not so important from the mesh itself, but they are really important for Tiberlab simulation. So we have put some physical entities here. So we save it. We have a physical line, which is the bulk. So the line 1 is the bulk structure, and we have two physical points, which will be very important from boundary condition, if in this case, since we are in one-dimensional case. So is the point 1 is the anode of the structure, point 2 is the cathode. Okay, now we just reload it again. Of course we do not see anything, but for if you go to here to tools and you put visibility, okay, you have the physical group here. So you have line 1, it's the bulk, point 2 is the anode, point 3 is the cathode. Here of course you can have also the elementary entities, line 1, point 2. If you select for example this, you select only this one. Okay, let's go back to here. So why these physical regions are important? Because these regions are the region that you have to use when you create the input file for the simulation. So every physical region here in this geo file will correspond to a physical region in the input file of Tiberlab when you have to insert, or you have to create it to define the property of this structure. Okay, here is almost finished. Now we can close. I suggest here from tools to open here this message console, which will give you all the information when you do those steps. At this point we can mesh it. It's 1D, so we go to mesh here, just open it, and we put 1D. Okay, the mesh is done. Here it's impossible to see because it's one-dimensional to see the point of the mesh here, but it's finished. Now we have only to save it. Okay, so you can see the Gmesh program just wrote another file, which is here in the folder. It's in the same folder where you have the geo file. We have a bulk _01.msh, which is the mesh file that we need to use for our Tiberlab simulation. Of course you can change the name, but by default it will have the same name but with different station as your bulk file. Okay, this very simple. It just give you an idea how to create a one-dimensional structure. In the second part of this tutorial I will show you how to use a Tiberlab input file for this specific structure.